I put the pressure on me big time. I probably will right away, but. All right, first thing before we get into today's topic is your unit is called transformations. So first let's go over what is actually a transformation. Bottom line, you're moving something around, moving a figure around, points or a figure. So up on the board here, I have a little portrait of the Mona Lisa here. All right, here's my original up here. Notice, did it move? So that's called a transformation. It's a specific type of transformation called a translation, a slide, but it's a transformation because the figure moved. All right, let me keep going. Here's another way I can move it. But it did move. So this, from here to here, I did some transformation. A transformation is when you move a figure. Moved? Yeah, I flipped it, but it's moved. And then here's another one. I blew it up. Did it move, though? So it's a transformation. 3 of these, though, have something in common that I just showed you. 3 out of the 4 have something in common. So when I move this figure, size or shape change? No, they didn't, right? The sides didn't change and the angle measures didn't change. How about when I did this transformation? Size or shape change? Nope. And how about if I did this one? Size or shape change? No. And what do I mean by size or shape don't change? They remain, a big vocab word we've used all year long. They remain what to each other? Begins with a C, ends in ungruent. Okay, good. And some of you guys are on top of your game today. Yeah, they remain congruent. So if a transformation results in a figure that's congruent to the original, we have a special name for that. And that's your first blank in today's notes. Anything that preserves length and angle measure. So, AKA, they remain congruent to each other. We're now going to refer to as not just a transformation, but a rigid motion. That is any transformation where the sides and the angles stay the same. Okay, any transformation where the sides and the angles stay the same, we call it a rigid motion. Now, we said, going back to my Mona Lisa diagram, 3 out of the 4 did that. 1 didn't, did it? That one didn't. So this wouldn't be a rigid motion. Okay, this is a dilation. All right, it's called the dilation. They don't preserve side length, but you know what is the same? The side length isn't the same, but the angle measurements are. All right, so in dilations, it does not preserve lengths of segments, but preserves angle measure. Okay, angle measure. So we okay on what a rigid motion, this new term is. A type of transformation that the original and the ending figure are congruent to each other. Now notice I kept saying original and ending figure. Can we get some good names for these now? So what I start out with versus what I end with. What we start out with, we're going to start calling that the pre-image. All right, that's going to be called the pre-image going forward now, whatever figure we start out with. And then we do a transformation to it. We move it. And then what we end up with, I know everyone wants to say post-image. Nope, just called the image. All right, that's going to be called the image. All right, let's see if we pick up on this rigid motion business. The one on the left is the pre-image. The one on the right is the image. So the one on the left, I did some type of transformation and got the one on the right. Does that look like a rigid motion was performed? Nope, why not? Change the size, right? The side lengths change. So this would not be considered a rigid motion because side lengths change. So this transformation would not be considered a rigid motion. What about the next one? One on the left is the pre-image. I moved it to the one on the right. Does it look like a rigid motion was performed? Yes, because side length and angle measurement look like it's preserved. So yes, rigid motion. Right, that term will be used throughout the unit, rigid motion. It's a transformation that preserves distance and angle measure. All right, we're going to go over one specific rigid motion today. One specific one that does not change the size or shape, and that is a reflection. All right, a reflection. I do not want to write the word reflection every time. I do not want you guys to write the word reflection. So we're going to have some symbols, notation for reflection. And it's not even a symbol, it's a letter. Lowercase r represents a reflection. Well, what if I did a capital R? No, that's reserved for another type of transformation we're going to do next week. All right, lowercase r stands for reflection. And you're not only going to see the lowercase r, you're going to see a subscript, something written at the bottom of it. And that's going to tell you what line we're going to reflect over. So that's the line of reflection right here. So there's two parts. The lowercase r tells you we're about to do a reflection, and the subscript's going to tell you what line we're going to reflect over. All right, so for example, here's something that could be written in this new notation, a reflection over the y-axis. That's how I would write that. So you know, by the lowercase r, you're about to do a reflection, and where you're going to do it? Over the y-axis. All right, ready? Ready to do some actual reflections with me. Before we start, I want to go over expectations in this unit. You will start noticing a lot of graphs. A lot of graphs. It helps to do these on graph paper. Which brings me to the homework assignments. In your textbook pages, it may say to graph. That's not optional. If it says to graph, you graph. Well, I don't have graph paper. Not an excuse. That's why this packet is so darn thick. Go to the last page of your packet. Just flip the darn thing over. Go to the very last page. Everyone see the last couple pages? What is it? Graph paper. There you go. So if your homework says the graph, you don't have graph paper, still not an excuse. You can go to the back of your packet and use one of those graphs. I do not and will never accept a ghetto graph. One of these bad boys. Drawn by yourself. Nope. Not going to happen. All right, you have graph paper available to you. All right, so there's just a little expectations as far as the assignments go. All right, so let's go back here. First one up. Everyone's going to take point A, 2, -1. Graph it for me. 2, -1. And we're going to call that point A. Right away, I'm using this new notation with you. What do I want you to do with point A? Lowercase r tells me reflect it. The subscript tells you over the x-axis. So let's talk, how's this whole reflection business go? When you reflect, distance doesn't change. And don't start getting freaked out. We're not using the distance formula. The distance from your point to the line you reflect over should not change when you put the image point. So my first question to somebody is, all right, how far away is A from the x-axis? How far is A away from the x-axis? How many units away? No distance formula needed. Hopefully we can count that. How far away is it? Hook, start us off right, Zoe. How far away? 1 unit. It doesn't change. So on the other side of the x-axis, I go 1 unit. So 1 unit away, reflect it, go another unit in the opposite direction. And there's the new point. And that new point is what? 2, 1. So it moved to 2, 1. Last thing we need to talk about, how do you name this point? It is no longer point A. Point A is right here. And I don't want to call it B, C, D, E, F, any other letter in the alphabet either. Anybody remember from your days back in the middle school how you name a new point? Good, yeah? There you go, yep, and it's called A prime with that little quotation mark there. Yes, that's A prime. So that is how we label images, with the primes. So this is going to be A prime. All right, let's keep going. There's other lines I want you to reflect over. So next one, take our same point A, 2, -1, and now reflect it over the y-axis. Y-axis. So how many units away is A from the y-axis now? Whoa, going deep there, Gianna. How many units away? 2. Distance remains the same, so I go another 2 units away from the y-axis, and here is A prime. And I still call it A prime because I did it on A. And what is our new A prime now after a reflection in the y-axis. What's that new coordinate for me, Ian?
-2, 1, or -1.
Good save. There you go. Are there any questions? Because those two, the y and the x, are the most basic reflections. Because now I'm going to start raising the level now. Any questions reflecting over those two lines? All right, next one. We're going to do bottom right here. Bottom right, bottom right. Reflect over the line y equals 2. What's that look like? Because I got to be able to count the distance, right, and match it. Where's that? What's that line look like? Y equals 2. Anybody remember from their graphing line days? We did a little bit of it in Unit 3, but graphing lines last year, y equals 2, y equals 2. And if you don't remember, that's okay. Good thing we have a calculator that can graph for us, right? So if you're ever unsure what the line looks like, here we go. We've never been to here before, but you go to Grapher, right? You go to Grapher. We haven't used this function at all yet this year. We go to Grapher, and you're like, I'm unsure what y equals 2 looks like. All right, graph it. Once it says to add an element, I don't know if you guys remember from last year, you can hit enter, and up pops a bunch of templates that you can choose from. I like y equals. Just get the x out of there and put y equals 2. And automatically it'll tell you what type of line it's going to be. But if you want to see it graphed, there's your line we're going to reflect over. And it even does x equals 2. You can just type in x equals a number if you forget what type of line. So going back to our problem, I'm asking you guys to take point A and reflect it over this line right here, y equals 2. All right, same questions I've asked the last two people. How many units away is A from y equals 2? How many units away? Ooh, there we go. Going deep. Gabby, hello. How many units away is A from y equals 2? 3 units away, so I'm going to go 3 units in the opposite direction. There it is. And what's that one there, guys? 2, 5? There's 2, 5. Question so far. I'm just going to get rid of these so I can do this next one. Any issues? Y equals is horizontal. X equals, which we'll experience in a couple minutes, is vertical. Whoa, how about this last one? Y equals X. Reflect over the line. Y equals X. Okay, hold on. Let me take a quick gander here. What does that line look like? Whoa! Diagonal. How do you reflect over that bad? Don't draw it on yours. Just let me do it on mine. How am I going to take point A and reflect it over that? Well, I can tell you what we're not going to do. Count. Oh, I'm just going to hit 1.5. So 1, I'll put it right there. No, you won't. Okay, we don't count. The only time we can do counting is if it's horizontal or vertical. So what do I do now when it's diagonal? Nice and easy for you guys. Know the rule. Know the rule. Anytime you reflect over the line y equals x, the line y equals x. Anytime I reflect over that line, the y coordinate is equal to whatever the x was, and your x coordinate is equal to whatever the y was. What am I saying in a nutshell? Flip the coordinates. Anytime you reflect over the line y equals x, you will end up flipping the coordinates. So 2, -1 becomes, flip them and we get -1, 2. And look where that ends up. Take a look. Look where that ends up. -1, 2. Looks like I flipped it over, didn't I? If I take A, flip it over, fold it over the line, looks like they'll match right up. So anytime you reflect over y equals x, you're not going to count. You're just going to remember the darn rule. Flip the coordinates. All right, flip the coordinates. All right, your turn. I'm going to walk around. Can you guys graph triangle ABC first? Graph it. Then let me see it graphed through the y-axis. All right, so this is on you. I don't need to know what the coordinates are. I just want to walk around and watch you guys graph triangle ABC with a reflection in the y-axis. And make sure it's a y. I always get a couple students every year do it over the x first. They get nervous. Everyone's good? Make sure we're all good on our diagrams. It's over the y, not the x. Also, directions-wise too, it doesn't say to state the coordinates. So that's why you don't see me doing, hey, everybody, what's A prime? What's B prime? It doesn't ask. And I only write it down if it says state the coordinates. All right, I only want to write it down if it says state. Anything before I change it up a little bit. All right, point X, 0, 5. Where is 0, 5 there, honors kids? I specifically picked that point so we know where it is. X or Y axis? Y axis, good. There we go. I always get nervous every year. Now reflect it through X equals 2. What type of line is that? And if you're unsure, we'll always graph it, right? Well, y equals was horizontal earlier, so this will be a little vertical line going through 2. So there it is. Reflect it through that line right there. All right, how many units away is x from x equals 2? How many units away here? Zoe, back to you. 2 units away, so please go 2 units in the other direction, and here is x prime.
Oh, wait, yeah, I'm number 2, so don't we get to do the
Well, that's a good point.
transition?
What?
Yeah, the answer is 2.
Yeah,
She's
same
number
number.
6.
You guys are just, yes, fine. You guys good, just grasping at it. Let me just finish this, please. What?
Do like the lines matter? Like when you draw the horizontal and vertical lines, it's like y equals. Like, do you have to use a ruler? Or does it not?
I don't even care if you put it on your graph. And I'm just showing you what it looks like so you guys can see that the distance matches. You don't have to draw that yourself. No, nope, not at all. All right, so that point is, and don't worry, yes, I know I got to do it. X prime, what's that point? That's going to be 4, 5. It's not like you guys are going to get it anyway, let's be honest. All right, just let me finish this problem and I'll do it. All right, I'll probably eat my words today. All right, next up, in all seriousness now, you really got to be careful this unit reading directions because you have to know, what am I reflecting? Now the case is I'm reflecting x prime, so I'm not going back to 0, 5. I'm going to stay with 4, 5 and reflect that through y equals -3, which now we know is a horizontal line. So take y equals -3. Oh, I love this problem too. I get so many of you freaked out. X prime, how many units away is it from y equals -3? How many units away is x prime from y equals -3 if I'm going to reflect over it? 9. Ian?
8.
8 units away. 8, right? Now some of you are like, oh yeah, I get it. 1, 2, 3, 4, 5, 6, 7, 8. And then you're like, oh, 1, 2, 3, 4. No more graph. I can't count. And you know you're not going to be pulling this business on me. Oh, look, I'm just going to extend my graph so I can count. Get out of here, honors kids. Get out of here. Just use a little algebra, please. You don't need to extend your graph. You know it's 8 units away, so you got to go 8 units from -3 away. Let me say that again. 8 units from -3. Come on now. You don't need to extend your graph. What's my final coordinate going to be here? After I go 8 units away from -3. Come on, be there for me. Be there for me. 7, Amy?
-11.
Just
Oh, wait.
-11?
Oh wait, my bad.
It is your bad.
-11.
4 -11. Perfect. Right? Because -8, going -8 units, down 8 units from -3 would be -11. Notice I didn't put a label on this. What should the label be here? Zeev? Prime. Double prime? Yep. X prime. Yep, double prime. But that only goes for if you transform the previous one, the prime one. All right, here we go. Let's get this misery out of here. What do you got? Whoa, look at everyone here contributing. So, somebody said something with the curtains. Genie, there you go, yep.
5 left. Drop.
Wish I got this most participation when I asked for a question.
Swing. Fade.
I already have swing. Missing a classic one. But there it is.
Is that all of them?
I think there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Got to be close. I thought there was always 15, but you guys have got to be close. You have 14 there. Let's see, what are we missing here? Swing, wipe, drop is there. That's always one people forget. Fade, clock, genie. I think we got them all. I think we do have them all. Pinwheels is up there, yeah. All right, here we go. Vote time. Ready? Slide right. Slide right. I like how you guys are trying to figure out how it's going to be a tie. Wipe. Cubes. Shatter. 3. Curtains. Pinwheel. Genie. Slide left. Drop. Book. Swing. Clock. Fade. Star. Okay, so swing and Promethean person, huh? All right, are we ready not to get it again? Are we ready? Is this your luck has changed now? Finally, after what? 25 weeks, your luck has changed. Swing or Promethean person. No homework for the weekend. Here we go. Ooh,
What is it?
we didn't get that, and that was the one we were missing. Curl, page curl.
I've never
Don't even.
Nah, it's not.
Don't even.
It's not
That's
a thing.
such garbage. It's not a thing.
Yeah, we do.
It doesn't
we do,
exist.
we do, we do.
No, there's no
That's
redo.
not-
There's no redo.
No.
Page curl.
No, it's not a thing.
That's not a thing.
What do you mean it's not a thing? Like I just made this up and programmed it in?
It doesn't exist.
Page curl.
They never showed us this.
It doesn't exist.
It doesn't exist.
We didn't know about that.
Yeah,
It doesn't
that
know.
was
We've been here
unfair.
25 weeks.
Never,
Yeah, we've never
I've never had
it.
page curl in 25 weeks.
You know where
No.
to get it.
Well, now you know you have it.
You know swing is there.
Okay, now you know you have it. All right, sorry, page curl. Now that was the one that was missing, I guess. Genie, there you go. All right, so there. We never had page curl. Baloney. All right, let's go.
He's gaslighting us that huge trouble.
Where is it? Where's my slide transitions?
Now you don't know where it is.
I know. It's page turn effects. There it goes. That's pretty small, huh? How do I make that? Everyone see it's all bug. How do I make
Can
this?
you put it on page trail?
It's on random right now. That's why the box is in blue. Just like, it's always been random. How do I can't make this any bigger. Where is it? It's on here. It's on here. Is it paid? No, it's not paid. That's a book.
I told you he's making it. It doesn't exist.
Where? No, it doesn't. It's on here. No, I'm missing. Look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So it's got to be on here. There's the Promethean person. Rotate. That's clock. Spin out is pinwheels. This. No, that's swing. Flip. Cube. Come on. Oh, there it is. Yeah, right there. Page curl. Yeah, thank you. So we're good now. It exists. All right, so get that back on random. There you go. All right, we ready now? All the complaints are done. Any more complaining? All right, we've graphed, and I'm just video recording all this. Good. We've graphed triangles and we've graphed points. The only thing we need to review is, all right, can I graph a segment? And yeah, we can graph a segment. So go ahead, graph segment FG for me. 3, 0. And make sure we make a segment out of it. Notice I'm starting to use your notation now. Lowercase r. Okay, I'm doing a reflection. And I know it's only reflections, but we have 3 other transformations to do. So reflection over y equals x. Oh, that's my diagonal line going through the origin. I can't count, but what I can do is, what's my rule if I'm going to go over y equals x? Rule we discussed already. Anytime you reflect over y equals x, what am I going to do with the coordinates? Here we go now. Ksenia, what do we have? Go ahead. You want to show off? Go ahead.
0, 3.
And
3, 4.
3, 4. Yep. Just flip the coordinates. So if I graph that one, 0, 3 up here, f prime, g prime 3, 4. Now, I know some of you may think that doesn't look reflected, but remember the line. Hey, I'll do this real quick for you. Remember the line we're reflecting over is this one. Yeah, if I fold my paper over that line, I think they're going to match up. So they are reflecting. All right, one last line I want to reflect over here with you is now y equals negative x. Y equals negative x. What's that line going to look like? Well, let's go back and take a look. That was y equals x. Y equals negative x. I'm sure you can already guess, but let's just make sure we're good. Now we go the other direction. All right. So again, can we count? Nope. So I'm sorry, but this is the final rule you're going to have to remember. Y equals x. I flip it. Y equals negative x. Anybody think they know? What do you think you want me to do to the coordinates y equals negative x? Doyle, got a suggestion?
You put positives to negatives and negatives to positives.
And flip. Okay, so not only am I going to change the signs, but flip and change the signs. And what are we, quick A, directions, what are we reflecting? Make sure you know we're reflecting FG, not the prime coordinates. So we're still going to call this F prime and G prime. So what would be my new coordinates after taking points F and G and flipping and changing the signs now? What are my new coordinates? Thomas, what are my new F prime coordinates?
0, -3.
And G prime?
-3, -.
Yep. And I promise you, those are the only two rules I'm going to have you do. Y equals X and Y equals negative X. Everything else you should be able to count here. All right, everything else you should be able to count. 0, -3. -3. And because we're in honors, remember that was the line we reflected FG over. So it looks pretty good. All right, one final task for me this week before we head into the weekend. You tell me what the line we reflected over was. All right, so yeah, you like that, Matt? We got triangle ABC. I'm going to do a reflection over a certain line, and I get the A prime, B prime, C prime triangle. You guys, what line did I reflect over? Okay, what line did I reflect over? And please use our new notation to tell me the answer. So a reflection over draw it in. If it helps you, draw it in first, and then see if you can write the equation of that line. When you're ready, what is my line of reflection here? Oh, here we go again, Thomas.
R X equals 3.
Yep. Was he a pirate? Never mind. R. No. Doyle, you got that. Good job. X equals 3. It was good. You like that, Will, I can tell. Anybody else? We all right? Okay, remember, graph means graph. It's not optional. And on graph paper tonight.